Today we're going to talk about the squeeze theorem. It's also known as the sandwich theorem. So you can call it whatever one you want. Both are accepted. So if you have a function f of x that's in between g of x and h of x for all x values except possibly at 1, then if the limit for g equals the limit for h, the two outside functions, then the limit of the other one has to be sandwiched between them. Okay, so here we go. It's a little bit of words here. So, but this is how you could think about it. It's a good way of thinking about it. Think of it as thousands of concert goers from all over the stadium leave the concert at the end of the night, and they have to go through a single turnstile. So you have tons of people squeezing through one little turnstile. Here it is, and then they go back to their parking lot. Okay, so we have this example here. If you use a calculator and you graph the functions, which I did here, and I pasted the graph. I used the Desmos online graphing calculator. It's a pretty good one if you don't have your calculator with you. Okay, so we have my red one is y1. This is y2, and then this is my y3 of my graph. Y3, there we go. So use the graphs to determine the limit. So here we go. The hard part is wording this. All right, so let's take the limit as x approaches 0 of x squared. That's 0. Okay, the limit as x approaches 0 of negative x squared. That's also 0. So since negative x squared is always less than or equal to x squared sine of 1 over x, and that's always less than or equal to negative x squared, the limit as x approaches 0 of x squared sine of x 1 over x equals 0 by the squeeze theorem. So it's an easy idea. It's just, look, this is squishing everything to 0. This is squishing everything to 0. And this is contained inside those, so it must also be approaching 0. That's the idea. Okay, the wording is the hard part. So here we have our last example, and we'll be seeing this back and forth for a while, so don't worry about it if you don't understand it right away. We want to find the limit of g of x as x approaches negative 1. Well, g of x is contained between these two other functions, so let's see. We have the limit as x approaches negative 1 of negative 3x. It's 3. The limit as x approaches negative 1 of x squared plus x plus 3. That's also 3. So since g of x is contained between these two equations, the limit of x, as x approaches negative 1 of g of x equals 3 by the squeeze theorem, or sandwich. There you go. That's it. That's the rest of 1.2. You have a lot of time to work on your worksheet, so go ahead and use it.